So the spring is 30, the spring is 5, and this is 10. This is 1. Here, let me ignore the unit, but the unit should be newtons, kilometers, meters, kind of these units. Okay. So here, in particular, here I consider a force. So we apply the force here, and then we call the F1t equal to 4 times cosine 10t. So that is the one force term applied. And this is our degree of freedom. So here is x1t, and here is x2t. Okay, so this is, so let me say x1 equal to 1, x2 equal to 0, and 1 dot, x2 dot. So last time we didn't consider the externally applied force. This time we consider this additional term here, and I believe this will answer the questions how to do that one. So let me start from here. So keep everything in mind, and we have all the information. So basically to solve for, we simply start from here. We simply start from these equations. Okay, so let me call this equation 1. So solution is this. We want to solve for find the total solutions x1t and x2t. Okay, so the solutions we start with equation 1. So that is this equation 1 here. Okay. So to get a state equation 1, how many information we need? We need m. So if you need, remember our M matrix equal to 10, 0, 0, 1, and our K matrix equal to 35, minus 5, minus 5, and 5, okay? And our FT matrix for this case is 4 cosine 10t and 0. This line representing a result from deriving the equation of motions. Okay, and that is part of the exercise from the very beginning of these chapters. Okay, so N and this K matrix. NK something is in terms of the matrix representations. So if you feel not comfortable with this one, then basically you need more exercise in how to do the equation of motion for multiple degree of freedom systems. And that one, you can refer to the very beginning of this topic here, okay? And then starting from here, then we can start with, so the next step is to solve for the natural frequencies, and that one we have done last time. So let me directly copy it, okay? So omega 1 squared equal to 2.5, that means omega 1 equal to 2.5 equal to 1.58, and omega 2 squared equal to 6, so omega 2 equal to 0.6, 2.45. And also last time we have the normalized mode x1, okay? So that one, what we have is 0.2673 and 0.5345. And the same thing, we have the second normalized modal vectors. Do you remember how to normalize modal vectors? And again, last time we have lectures, we have the content calculations. Simply is to implement this one. right? So the same example, okay, so you should have all the information in place. So again, to this moment, if you feel, hey, how do I do this one? Then again, do the exercise. I think homework 13, 12 also have that one, okay? So keep everything ready, then basically we have our modal matrix equal to X equal to the combinations and 0.26. Okay, let me write it again. Everything ready, then we are able to utilize equation 1, and I'm going to plug in all the informations. And if all the calculations are done correctly, you can simply, you don't need to recalculate this again because that theory tells you the result. You simply copy it. The bottom line is as long as your model vectors are calculated correctly. Okay, so let me direct copy that one. So therefore, equation 1 is we have Q1 double dot plus omega 1 square Q1, okay, equal to, that I get, let me do this one first. Okay, so the xt, let me write it again. So therefore, equation 1 becomes 1001 Q1 double dot, Q2 double dot, plus, and let me using the symbols quickly because if you like, we can put the numbers here. So that is omega 1 squared equal to 2.5, omega 2 squared equal to 6, and Q1, Q2. This one is this matrix. Okay, so I have utilized the numbers for omega 1 squared, omega 2 squared into here. Be good? Okay. And this one equal to this transpose multiplied with 4 cosine 10t, and this one is regarding, I think, your homework 13. That is from here. So that should be question regarding this one. Okay, start from here. To implement this one, so we simply plug in the transpose. And this matrix transpose, right? The X is transpose. Again, the transpose is this. We using the diagonal element as a pivot, we tilt it. And for the second one, we're using this element and tilt it. So it transposed result becomes like this, 0.2673. Okay, so multiply with 4 cosine 10t and 0. So this result, I have a calculation that will equal to 1. Okay. So implement this calculation, we have this one. So therefore, equation 1 becomes this Q1 double dot plus 2.5 Q1 equal to 1.096 cosine 10t Q2 double dot 6 Q2. Okay. And then the initial conditions.
I missed it.
Yes.
You got the 1.069 cosine 10t. Where did you get the 1.069?
That one is because you calculate this multiplication, the first row multiplied with this column equals this number.
Okay.
Got it? Okay. So right now here we have the Q1 0 equal to something, Q2 Q1 dot 0 equal to something. And Q2 equal to something, Q2 dot. The initial conditions are starting from our last time. So this one, C, our last lecture. Basically, implementation is to utilize these two equations here, okay? And that is very straightforward. We have done this one last time. So this one, the number is 2.6726. This is 0. This is 0. This is minus 1.6903. Okay? Good? Okay. Then again, do you know how to solve for these single degree freedom vibrations? This is a harmonic vibrations of single degree undamped systems. In chapter 3, let me copy here. So from chapter 3, we have such a formula. Okay, and also you have exercised a lot, so refer to there. Okay, so for this case, you should be able to solve for Q1T. Use the chapter 3 informations, and this information available also in the homework 13, the tutorial 1 information, but textbook, your note lectures should have this information. So here we can solve for Q1T is equal to 2.6836 cosine omega 1T. And here the omega 1 is what we have is 1.58. Okay, I just using the symbol not to cause any confusion. It's 0.011 and cosine 10T. So you see this such equation combined the free vibration that is governed by our natural frequencies. The second term is the cosine with 10T. 10 is our working frequency, that is force vibration. So basically the solution combines both. Okay. And Q2T have the similar patterns here. That one equal to minus 1.6975 cosine omega 2T, and again the omega 2 is our natural frequencies, and that is 2.45 and plus 0.772 cosine 10T. So again, for the response of Q2, we have such two terms here. First term is regarding the involved with natural frequency, so that is influence from free vibrations. The second term is involving our working frequency, that is 10. Here we are given is 10, so the second term is involved with the forced response. Okay, so the questions for homework 13. So right now we have everything, And we are ready to answer what is this one, x1t. So we simply utilize this. We utilize this one, so therefore x1t, x2t. Again, we utilize this information. That is a model matrix. What is our model matrix? Let me copy that one here again. So that is 0.2673 minus 0.169. Times Q1, Q2. Okay, and what is Q1, Q2? So again, not to copy this one, Q1, Q2. Let me copy the Q1, Q2 to here. So something like this one. So how to implement the result? You see, this is a 2x2 matrix. 1, 2. This is a 2x2 matrix and elements like this. And this one is column vectors. So multiplication of such things, although it is long writing, but do it patiently. The first row multiplied with this column that gives us x1, right? So therefore, x1t will be equal to the first row. That is the two numbers multiplied with this one. Good? And here in my calculation, I spent time to implement my MATLAB program to do all the calculations. I don't trust my punching. No, it won't work. I remember last Saturday night, I do it 3 times with the very simple, not even scientific calculator, just regular accounting calculator. 3 times, 15 minutes. Each time I got wrong the different answers. And then I give it up, and then I don't have a MATLAB at home, so Monday come back here. I do it in MATLAB here. Okay. So for this one, if you like, you can try it 0.2673 multiply with Q1t. Okay, so this is the Q1t minus 0.169 times Q2t. And what is Q1, Q2? You simply plug in those information carefully. So basically that result should be in combinations. Let me write it up here. And so that one will be like this. 0.7172 cosine omega 1t. Q869 cosine omega 2t minus 0.0041 cosine 10t. So Raymond, that is your questions. That is a coefficient. In the homework 13, I put some labels A, B, or C, D to whatever the coefficient here, and leaving other numbers for your reference, for you to benchmark your calculations. If you done right, then whatever the number appear, you must match that one. So, be good? Okay, then you can repeat x2t, and that one should be equal to, again, x2t is the implementations of the second row. That is these numbers here, this number and this number multiplied with this one. So x2t should be equal to 0.5345 times q1t result is 1. Like this. Okay. So this is a very thorough demonstrations, and for these demonstrations, I have utilized the harmonic force like this. Okay. So this harmonic force will appear, where information will be appearing into somewhere like here. Okay. So if we are dealing with different type of the force, then that information will also appear on the right-hand side of either of the two equations here. So basically here is a decomposition, decoupling into the simple single degree freedoms vibration problems. Okay, so before I came today, so probably we done for this.